Okay, well, this is the greenhouses we're putting up. Each one is the 14,000 square foot footprint, including the little surrounded. Effective grow area is 13,660 square feet, and because we've got up to 130 mile an hour prevailing winds, we did the curved roof so that we don't get rattles and a lot of noise with throbbing. So the panels are slightly stressed, and they are perfectly quiet. We had a 68, 70 mile an hour with the rain and everything we had last week. Not a whisper out of the building, so that was good. The exhaust fans that you can see, we got 5 on each side. The part of the global environmental control that we're using in there, we've got in each set as a standard package 4 evaporative coolings at 10 horsepower each, that is our own proprietary system, and 10 exhaust fans. And everything is on inverter control. Nothing is on hard or off hard. So in the winter, you wind it back down. A 10 horsepower motor it becomes a 1 horsepower motor at 5 hertz. So we keep the electrical uses at the absolute minimum, and we got to keep this below 80 degrees when we are 124 degrees outside. So we got a lot of studies done on how to keep the system cool and control the ambience, to control the humidity, control all of that is under a central computerized system. But apart, we use radial fans again because actual fans with the hand wind, they wouldn't be reliable. And they are auto light depth to a point, so that we don't have to worry about light penetrating in when we got the blackouts deployed. So anyway, all the walls are MGOs. They are fireproof, waterproof, and everything else proof. You can see from the inside the structure, there is 2 walls. The R value is around 36, 37 on the walls, but only about 6 or 7 in the roof, because we want the light to get through. So it's been quite a extensive study to do something that works reliably and a long time in the desert. So now just go and take a look. One is clad. That one is just finishing off the roof. The last one needs the little bit of a paint, and it's fast. All the structure, the skeleton, so to speak, is all up.
Okay.
And it's another thing to mention is that everything is modular. So if you want to move that evaporative cooler to the next bay, it's a piece of cake. This goes there, panel goes there. If you want to add exhaust fans, the cooling units, everything, it just plugs in to a module system. The sizes, the cooling system is the size of 1 panel, minus a foot on top for leverage. And when you go inside, you can see how strong it is, because that cooler is about 2 tons and is cantilevered off the wall of a greenhouse. Is something new. So have a look. There's going to be a revolving, like a Paris style, revolving door, that so that we don't get air flushed in too hard, that the general in and out scenario. And as I was saying, look at that evaporative cooling system.
Oh wow!
It's cantilevered off the wall. And then the exhaust fans are all radial.
And that's MGO board?
This is actually the outside is the MGO. This is expanded polystyrene. Another set goes on top.
Oh,
That, negative. So we have a 2-inch insulated 2-inch, 2-inch air gap, another 2-inch of wall. So it's a double wall. It's very robust. And these exhaust fans are pretty oversized, because at full, in August day, let's say we got 120 something degrees heat, these can, they will be rated at 7 horsepower each. The evaporative coolers can ramp up to 15 horsepower each, but as I said, everything is under a central command. The RPM drops, voltage drops, power consumption drops. So you only pump in the power only when you need it. And if you don't, you back off and you're pretty reliable. And our air handling system is 250,000 CFM. That is 250,000 cubic feet per minute.
could you say that again?
250,000 cubic feet per minute of air we can push in and out. So that is if we are very humid day, which is very rare in the desert, but it does happen, and we get 120 degrees with humidity, then we will need the full capacity of the system, pumping in 250,000 cubic feet of air in and out to maintain the temperature below critical point. So, and our roofs are pretty robust, and as I said, they are curved rather than pitched, because we got very strong prevailing winds, especially east-west. We can get up to 130 mile-an-hour winds. So the building is designed for seismic D, which is, we are close to San Andreas Fault, and we are 140 mile-an-hour certified.
Awesome. So 14,000 square foot. How many of these do you have going?
Well, the first 3 are going up as we speak, as you photographed. And we got a lot more. This is a 160-acre complex, so there'll probably be another 20, 30 units. And we are sent to the factory. I brought in over here site.
That's the polystyrene board with the MGO board, the magnesium oxide right here. Stuff is badass, man. Fireproof. Wind, there's no bugs. So this will be on the exterior. This is the interior installation, and they'll have the same MGO on the interior. And that's it. Shaka bra.